Okay, for the classifying triangles foldable, you're going to need your notebook, you're going to need your glue stick, you're going to need a multicolored pen or colored pencils. If you don't have that, just a pen or a pencil will be fine. If you were in class, you folded this, but in case you weren't there, the foldable is actually two pieces of paper like this. You're going to take the one that says scalene triangle on top. The sum of the angles in a triangle is on the bottom. And if you look along the bottom, what you're going to do is slide the scalene triangle one up so that at the bottom you have overlapping triangles and other info just a little bit below classifying by congruent sides. So it should look like a little flap here and then this here. And then what you're going to do, take the top and you're going to fold it down. Now don't fold it all the way. You're going to fold it so that you keep uncovered the classifying by congruent sides. Fold it like this. Okay, and so if you happen to have a stapler, that would be useful to staple once right here. If you don't, it's not that big of a deal. It might not stay in too well, but that's how you set up the classifying triangles foldable. Alright, so I would recommend with all these foldables that you do them first and then paste them in, but you don't have to do it that way. It's just a little easier to write. So what I'm going to do is open up this first flap, okay, and we're going to fill it in. So the sum of the angles in a triangle is 180 degrees. So all three angles in every triangle, if you add them up, you get 180 degrees. So one type of triangle, this is classifying by types of angles. Okay, so this triangle here is called an acute triangle because all three angles are less than 90 degrees. Now how do we know that this one right here is less than 90? Well, if we take 85, this one here, and 35, this one here, add them together, we get 120, and since all three of them have to equal 180, that means that this one has to be 60 degrees. So all acute angles less than 90. Another type of angle that is classified by the angles is an obtuse triangle. It has one angle that is more than 90. Now, let's just say that we know that these two other angles, the acute angles, are equal, and we know that this is 130 degrees. We can find the other two, again, because all three have to add up to 180. That means there's 50 degrees left to split equally between those two angles, so that 50, if we divide by 2, we now know that each of these has to be 25 degrees. 25 plus 25 plus 130 is 180 degrees. For a right triangle that has one angle that is exactly 90 degrees, that is indicated by this box here. That's the 90-degree angle, the right angle. Because the three angles have to add up to 180, if these other two angles here and here, so I'm doing it in purple and orange, what this tells us is that since we have a 90-degree angle, if we take the other two, they must also add up to 90. That's what we call complementary. Okay, or you could just go through the whole thing and say, well, they all have to add up to 180. So that's classifying by types of angles. We've got acute, obtuse, and right. All right, so this is the section classifying by congruent sides. So what I did is I lifted these two up so that I have these three things by congruent sides. So there's three of these. There's scalene, which means no equal sides, no equal angles. And how we do that in geometric notation, this side is different than this side, which is different than this side. So those indicate that those sides are not the same. Same with the angles. This angle is not the same as this angle, which is not the same as this angle. They have different arcs in them, so they're different. So that's scalene. Nothing is the same. Then we have one that's important in geometry called isosceles. An isosceles triangle has two equal or congruent sides and two equal or congruent angles. So these two might be equal, and this one's not equal to those other two. The angles opposite those equal sides are also equal. So these two angles down here are also congruent, and then this one up here is not the same. This angle here is actually something called the vertex angle. Okay, and then equilateral has 3 equal sides and 3 equal angles. So all 3 sides are the same. All 3 angles are the same. Now, because all 3 angles are the same and all 3 have to add up to 180, that means that each of those angles in an equilateral triangle is 60 degrees. No matter how big or small an equilateral triangle is, those angles all equal 60 degrees in an equilateral triangle. Okay, so this last section, overlapping triangles and other info, open that up, and basically there's not much to write at the top here. It's just a Venn diagram showing you that you can have a triangle that's obtuse and isosceles if it has an angle that's more than 90 and it has 2 equal sides. So this one equal to this one, and then this angle would be an obtuse angle. You can also have an acute isosceles, so it's all of the angles are less than 90 and it also has 2 equal sides. So that, and then all 3 of these are acute. You can have a right isosceles triangle. One angle is 90 degrees, so let's call it this one. Okay, and then 2 equal sides, so one here and one here. Now what that also means is that since these 2 sides are equal, these 2 angles are equal, which means that they both should be 45 degrees. 45 plus 45 plus 90 is 180. Okay, the other info is down here. The height of a triangle makes a 90-degree angle with the base, either inside or outside the triangle. The height of a triangle is also called the altitude, not the trampoline park, not the height of a mountain, but altitude of a triangle. So in these diagrams, this dashed line here, that's the altitude, or height. This one right here that makes the 90-degree angle symbol, or 90-degree angle with the bottom, even though it's on the outside, that's the altitude, or the height. So if you wanted to calculate area, the area of a triangle is 1/2 times the base times the height. So for this one, we would do 1/2 times the altitude or height is 14 times the base 10. I would do that on a calculator, and I would get 70 square units. There are no units, so just square units. Over here, we would have to do 1/2 times the base, which is 13, times the height, which is 10. 1/2 times 13 times 10 is 65. 65 square units. To do that, remember, to find the area of a triangle, you got to have that straight up and down 90-degree angle to the base line called the altitude or height. Alright, so once you have all that written down, we're going to close up the foldable. Alright, we're going to flip it over to the blank side. We're going to take our glue stick. You don't need a ton. I'm going to go around the outside. I might leave this little flap unglued, so right where the staple is, a couple of stripes. Take your notebook, next page, and I'm just going to glue it right here. Okay, I'm going to label this classifying triangles, even though it's labeled right here. I'm going to still classifying triangles. Okay, and now you've got that in there for your reference.